You've probably all seen the trick where you rub a rubber balloon against your hair and then you put the balloon against the wall and the balloon sticks to the wall. The effect you're seeing is called the triboelectric effect. The triboelectric effect is highly dependent on the materials being used. Not all materials will work, and which two materials used together is important too. Rubbing two balloons together, for example, won't work. But as you saw, a rubber balloon with human hair does work. A list of what materials work is called the triboelectric series. Here's a short list with some materials. The order of the materials in the series is very important. Some are on the positive side of the list, and some are on the negative side. Also, the farther apart the two materials are in the series, the better it works. So rubber, like a rubber balloon, is far apart from hair, so they work well together. But amber and wool are very close together and won't work well at all. Here's a piece of vinyl which I cut from some old window blinds. And here's a glass. You can see that the vinyl and glass are far apart in the triboelectric series, so they should work well together. Just make sure you clean the glass first. We want glass, not grease or dish soap. To see if it worked, I'm using a homemade electroscope. If the two aluminum foil leaves in the jar spread apart, then it worked. Let's use our vinyl and glass example. We'll go right down to the individual molecule level. Vinyl is made up of vinyl molecules and glass is made up of glass molecules. A molecule is simply a collection of atoms bonded together. Vinyl is made up of hydrogen and carbon atoms and glass is made up of oxygen and silicon atoms, though it's not too important to know which atoms are involved. If we add up all the parts of the atoms, vinyl is made up of 15 positive protons and 15 negative electrons. Glass is made up of 66 positive protons and 66 negative electrons. If there are the same number of protons and electrons in a molecule, then the molecule is neutral. It's neither positively charged nor negatively charged. Now what happens if we bring the two molecules together, like we were doing when we rubbed them against each other? When they get close enough, they form an electrochemical bond. It's as if we formed a new, bigger molecule. But most importantly, when the bond is formed, electrons move from the glass molecule to the vinyl molecule. In this case, 3 electrons are changing places. As a result, the vinyl now has 18 negative electrons, since that's where the 3 electrons went, and the glass now has 63 electrons, since that's where the electrons came from. Since the vinyl now has more negatively charged electrons than it has positively charged protons, the vinyl is negatively charged. And since the glass now has more positively charged protons than it has negatively charged electrons, the glass is positively charged. And if we then move the molecules farther apart again, the electrons don't go back to where they were. The vinyl stays negatively charged and the glass stays positively charged. And that's exactly what happened when I rubbed them together. The molecules are repeatedly forming bonds, then moving apart, forming bonds, then moving apart. The more I do this, the more electrons move from the glass to the vinyl. And the more negatively charged the vinyl becomes, and the more positively charged the glass becomes. And now you see why the vinyl is on the negative side of the triboelectric series, and glass is on the positive side of the triboelectric series. Rubbing vinyl with glass makes vinyl negative and glass positive. Humid air makes it harder to charge things up, so dry air is better. This is a relative humidity meter. Right now it's at 60 and I had no trouble charging up the glass and the balloon. But when it's around 80 or 90, it doesn't work as well. So if you're having problems, that may be the reason. Some other examples of things to try are rubbing socks on a carpet and getting a shock when you touch someone or a metal door handle, and running a comb through your hair. Remember, it all depends on which materials are involved and on the dryness of the air. Some other examples are that a car sometimes gets charged and you get a shock when you go to touch the door handle. And the non-metallic rollers and belt of a Van de Graaff machine are charged by triboelectricity. Well, thanks for watching. I hope you learned a few things. There are more videos with electrostatic topics in the Science and Tech playlist on my YouTube channel, rimstar.org. There's even one about how to make your own electroscope, and others on Van de Graaff machines. And don't forget to subscribe if you like these videos. Bye for now.